Week 2, Florida Virtual 5.01, 7th grade math, scale drawings. After completing the lesson, you should be able to say, I can use ratios to create a scale drawing, I can compute lengths and areas from scale drawings, and I can solve problems involving scale drawings. Scale drawings, Florida Virtual Module 5.01. So when we're looking at a scale drawing, we're looking at like a blueprint that's the drawing for an actual house or building or whatnot. So when we're looking at a scale drawing, it's used to represent real or actual dimensions. And our scale factor is a ratio of two corresponding lengths that determines the change in size from a pre-image, which would be like our drawing, our blueprint, to the actual image, which would be the enlarged version or a new size. And it could be that we're going from the enlargement and we're going to do a reduction and make it smaller. So a scale factor that is smaller than 1 will scale an item down to smaller dimensions. And when we're looking at examples of scale factors that will scale down, we're looking at like 1/2, which is equal to 0.5. We might have 1/4, or you could use 0.25. And we might even get a fraction like, let's say 2/3, which is equal to 0.6 repeating. And then this you would probably just use as an estimate, or better yet, we would take and just multiply by 2/3. Now, a scale factor greater than 1 will scale an item up to a larger dimension. So examples of scale factors that make something larger are like 3/2, which is equal to 1.5. So we can express it as a fraction or a decimal. We might use like 5/2, which is equal to, let's say, 2.5 here. And we might even have a whole number like 3. It doesn't have to be a decimal or a fraction. And then you might get something like this where you have 7/3, which is equal to 2 1/3, or 2.3 repeating. So when we're using this, the scale factor is blank by each dimension to calculate the new dimensions. And we want to, it is multiplied. And as we start working through these problems, we're going to use that scale factor to multiply on each side to find the new dimensions, whether it's an enlargement, getting bigger, or a reduction, getting smaller. Mario wants to create a scale drawing of the poster shown. What are the dimensions of the poster at 1/5 its current size? So when we look at the poster, we see that it's 90 centimeters by 140 centimeters. So this is number 1. So we know that it's 90 centimeters by 140 centimeters. And it tells us our scale factor is 1/5. So I want you, just make a little note, I want you to remember that multiplying by 1/5 is the same as dividing by 5. So let's set up the first one that we need to decrease in size. So the first side is 90, and we're going to multiply that by 1/5. So I'll put that 90 over 1. So this is our side times the scale factor. So this is step 1. 90 times 1 is 90, 1 times 5 is 5. And then step 2, remember that fraction bar is a division sign. we want to divide. 90 divided by 5 is equal to 18. Now the next side, 140. So it's 140 times 1/5, meaning we're taking that 140 over 1, our side, and then we're going to multiply it by the scale factor of 1/5. We don't need to do that. So step 2, 140 times 1, 1 times 5, and let's divide. 140 divided by 5 is 28. So when we're looking at the answer here, it's not just 18 by 28, but we need to actually use those units. So this is 18 centimeters by 28 centimeters. And if you notice, that is a reduction, dividing both of those sides by 5. Number 2. Next, Mario wants to enlarge the same poster by a scale factor of 3/2. What are the dimensions of the enlarged image? So again, like the last one, let's start with writing down our 2 dimensions. This is a 90 centimeter poster by 140 centimeters. And again, remember, here we're going to multiply by that scale factor of 3/2. So let's take the first side, 90, and we're going to do the same thing, but this time we're going to multiply by 3/2. 3/2 is really 1.5, 1.5, but we're going to use the fraction. So number 1, we want to take the side times our scale factor. 9 times 3 is 270. 1 times 2 is 2. And just like the last problem, the second step, we're going to divide. 270 divided by 2 is equal to 135. And notice that side now has increased. Then we're going to take the next side, 140 centimeters, and we're going to increase that by a scale factor of 3/2. So again, number 1, we want to take the side times the scale factor. So let's multiply across. 140 times 3 is 420. 1 times 2 is 2. Second step is we want to divide. So 420 divided by 2, you can use your calculator, is 210. So just like the last problem, we're answering what are the dimensions of the enlarged image. So it's 135 by 210, but again, we want to use our units. So 135 centimeters by 210 centimeters. Number 3, a radio station wants to enlarge a poster into a billboard. The original panoramic poster is 2 feet by 8 feet. They need to use a scale factor of 6 to enlarge it to billboard size. What will the area of the poster be after it is enlarged? So we can see that our dimensions are 2 feet by 8 feet. So let's start again. 2 feet by 8 feet. And we have a scale factor of 6. But we also need to make a note that we are finding area. As just remind yourself, because this isn't like the last two problems where we're just finding the dimensions when it has been enlarged or reduced, but we want to actually find the area. So there's a lot of steps here. So the first one is we want to find the billboard's dimensions. So number one, we have the side that's 2 times 6. So remember, this is our side times the scale factor. So the side times the scale factor, 2 times 6 is equal to 12. And the second dimension is 8. And we're going to multiply that again by our scale factor of 6. So we take our side times the scale factor. 8 times 6 is 48. Now from here, we need to find the area. So first is our new dimensions. And secondly, we're going to need to find our area. And I want you to remember area is equal to length times the width. So we're just going to take that 12 times 48. If you use your calculators, 12 times 48 is 576. So 576 isn't our final answer because we need to use the units. So our answer is 576 feet squared. Don't forget this. If it gives you inches or yards or something different, just be cautious. And again, you're not taking the area of the original one and multiplying by 6. 2 times 6 is 12, but 12 times 6 is not 576. So just be careful. You can't multiply this area and get your answer for this problem. You have to increase the two sides and then find your area. Number 4, a scale drawing of a swimming pool and deck is shown. What is the area of both the pool and deck in square feet? Round your answer to the nearest whole number if needed. So just like the first 3, number 4, we're going to start with the pool and deck dimensions. So it's 13.2 inches by 16.8 inches. And it tells us that the scale is 1 to 50. But what does this mean? So what that really means is for every inch in the drawing, it's going to be equal to 50 inches in real life. So the first step is we're going to multiply both sides by that scale factor here of 50. So we're going to start with that 13.2. This is one side of the pool. And we're going to multiply that by 50. $13.2 times 50 is 660. The next side is 16.8. And again, we're going to multiply by 50. So again, you can try this out on your calculators. 16.8 times that 50 gives us 840. And if you want to make the little note here, this is again side times that scale or scale factor here. So this is the actual side length in inches. So this is our real side lengths. However, if we go back into our problem, it asks for the area of the pool in square feet. So we know the inches. So the next step after we found the dimensions in real life, we need to convert the inches into feet. And we know that 1 foot is equal to 12 inches. So we're going to take the 660, divide by 12, and then also the 840, and divide that by 12. Let's try the first one. 660 divide by 12 gives us 55. And the next one, 840 divide by 12 is 70. Now, this is just the side lengths of the real pool deck. This is not our answer. When we go back to our problem, it asks us to find the area. So third step, we need the area. And again, remember area is equal to the length times the width. So we're just going to take that 55 times 70. When you multiply those, you get 3,850. And this is our actual area of the pool, deck with the pool. So the answer is 3,850 square feet.